Hey guys, what's up? Welcome back to AlgoYogi. Now we are doing stack series. We're still doing the easy problems, and our next problem on the list is make this string great. Let's go to LeetCode, give it a read. Given a string S of lower and uppercase English letters, a good string is a string which doesn't have two adjacent characters, where basically these are the two adjacent characters, where this is the condition. I lies in the range 0 to n minus 2, basically the length minus 2. That means we're excluding the last character because that's what we are comparing with, and we are just defining the condition for I. And the character at ith index is a lowercase letter, and next to it is the same letter but in uppercase, or vice versa. So those two characters, they both have to be, one is uppercase, another is lowercase, and it could be basically the position could be switched. To make this string good, you can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string becomes good. So return the string after making it good. Okay. The answer is guaranteed to be unique under the given constraints. Okay, notice that empty string is also good. All right, so we kind of understand so we are given this string right over here, and we need to check if it is a good string or make it good. All right, so we're not only checking, we're making it good, but it might be potentially bad, it might not be bad. So how do we check it's bad? We check for these conditions. These are the conditions, and whenever you come across two bad letters together, we just remove them and again recheck whatever you've got if it is good. So let's say we go over this particular string. If you see over here, these two characters justify these conditions. They lie between this range. If this is my I, which is smaller e, and then next to it is I plus 1 is upper e, these are basically satisfying our condition, both of them. So what do? We just get rid of both of these letters, and then whatever you are left with, then you again check if whatever you have got is good string or great string, or it has any bad string. So after deleting both of these, we get LE, E, sorry, my bad, not these. So EE, T, C, O, D, E. Now let's check again. These two are not same, these two are same, but they do not satisfy the condition because one of them has to be uppercase or lowercase. They're both lowercase, so one of them had to be uppercase. These are not same, these are not same, these are not same, these are not same. So we return, this is my great string. This is what I return. This is my answer. All right, so brute force approach of doing this would be you start with the original string, and then you keep checking if you find any two letters, adjacent letters, that justify these two conditions, then delete, join remaining strings, and then again perform the same operations. But I think there is a better approach. What is the approach? Let me just get rid of these conditions because we understand them. Better approach is using a stack. How about I have a stack where when I'm iterating using my I at first letter, then I check if my stack has something on the top. So right now there is nothing on the top of my stack, so what I'll do is I'll just append that letter to my stack. So I'll append L over here, then I go to my next character, then I go to my next character, which is E. Then I check if it matches. I'm going to basically convert them to both lowercase or uppercase and check if both of these, the top of my stack and the current character at I, are they equal if I convert them to both lower or upper. In this case they're not, so I'm going to append E to here, and now my top will be basically E. So I'm just gonna not have this, and then I will come come on the third index or second index, E letter. Then I check if top of my stack matches with this. Yes, it does, because lowercase of e equals to e dot lower. This is true. This is true. So what I'll do is I will pop this and move on to the next letter. I will pop this out. Okay. Then now I pop so these two are gone kind of from the string. Alright, so now I will be at this E. Then I check if this matches with the top of my stack, which is L. It does not, so I'll push this onto the stack. Then I check if this matches with the top of my stack. It does, but there is also one condition. These two needed to be, either basically they can't be same. One of them had to be uppercase here, but they're not, so we will basically keep appending it. Then T doesn't match with this, so I'll just keep pushing these like that, and then finally I will basically join them with delimiter. Okay, I shouldn't be writing it over here, so I'll just write it here. Join, because it's an array in a way, so I'll just, whatever stack I had, this will be my answer. I'm appending them, all of them together with empty string, and then returning that answer. So I think that is all. That's all we will be doing over here, which will be of big of and time complexity and same space complexity, because we are going from left to right, trading over all the n letters. So, and how we are going to, let's find out, because it's an easy problem. I don't want to waste my time on it too much. We have more important problems later. Okay. So I'll have a stack, empty stack. Then I'm going to trade over for ch in s. For ch in s. Two things. First is if my stack has something, if my stack is not empty, and the ch dot lower equals to top of my stack will be stack, I'm getting it like peeking the top element, dot lower. These are equal. That's one condition. We also have to check they're not, one is upper, another is lower, or first is lower, next is upper. So in order to check that, let's have an AND condition here, that ch is not equals to the top of my stack. Okay, see this. If this is the condition, then I'm gonna pop the letter from my stack, else I will basically append it to my stack. Append ch. I think this makes sense. So this here I'm checking that either of them, they're not same. They're same, but they're not same. It's a tricky way of saying it, but I'm checking they both represent the same letter. That means they could both be lower, both be upper. One is lower, another is upper. One is upper, another is lower. But at the same time, they are not both lower and not both upper. That makes perfect sense, right? So, and now in the end, we will just return joining them together, because it's an array, and this is a way of joining in Python an array, all the characters in an array, if they're string, together. And just that's it. I guess I'm gonna zoom out now and run it on examples. It was an easy problem, so really minor problem, because lower is a function. It needs to be used like a function. It needs to be called like a function. All right, so I think this should be good. And Python doesn't give you like error like that. It doesn't tell you like what's wrong, because you had to call it like a function and not just like a property or something. Okay, so let's submit it. Awesome. Let's write down the time complexity. This is going to be big of n. Space complexity is going to be big of n as well. All right, let's go back to AlgoYogi, mark this solved. See you guys later in the next problem.